Hi all, welcome back to another lecture of DBMS, and in this lecture we will learn about inheritance in DBMS, like how inheritance comes into the picture of operating object-oriented programming language. Here we will learn in DBMS. So how basically inheritance means in DBMS and what are its types. Along with that, we will learn about single versus multiple inheritance. Then we'll see the concept of overlapping and disjoint subclasses. Then we will learn about partial participation and total participation in ER. So let's begin with the very first topic, which is introduction of inheritance. We know that inheritance allows entity to inherit the properties and relationship from other entities, which will be its parent. It established a hierarchical structure where a parent entity can pass down its attributes and behaviors to the child entity. So like how it's done in the object-oriented programming language, like we will having a parent class A and child class B, C, D, right? So every child class can inherit the properties, attributes, methods, which are already mentioned in the parent. So here in terms of DBMS, we'll talk about attributes and relations, which is there with the parent. It can be inherited by the child entities as well. So this basically promotes the schema reside and simplifies the modeling process by enabling the creation of more specific entities based on the general ones. So instead of recreating the attributes or recreating the relations between the child entities, we can directly inherit the properties or relationships from the parent, and we can recreate. We just need to create the child entity with all those features which are already there in the parent entity. So basically it helps to simplify the modeling process. So for example, here is a person class and we have passenger and teacher class, and we know that the attributes like user ID, name and phone number will be common attribute in this subclass also. So as the child passenger and teacher are the child classes for this parent class person, so all these attributes can be inherited by the parent passenger class and the teacher class, along with their individual attributes also if they want to add, like how passenger added passenger ID, age and gender. So along with these three, passenger is allowed to inherit these three attributes of the person as well. Similarly for teacher, they have driver ID, license number and current train ID, along with the three attributes which are already there in the parent class or parent entity as person. So this is what inheritance mean and how does it looks like and why it is so important. Next is single versus multiple inheritance. So single inheritance involves a subclass inheriting from only one parent. So one child class has only one parent, okay, either mother or father, let's suppose, and it inherit all the properties of mother itself or if father itself, okay. So this is the example of single inheritance. So here it's a less chance of ambiguity since there is only one parent to tell. So let's suppose we have name as an parameter or attribute from the parent class. So child class can inherit that name, but if there is only one parent, there is no problem. But in case of multiple parent, it can be inherited by multiple parents. Like a child can have attributes, or a child can have behavior of mother also and father also. So let's suppose in this, if we have name as an attribute in passenger also and name as an attribute in payment also, so in that case booking will be confused like which name it needs to take, right? So that is basically the ambiguity problem which occurs in the multiple inheritance, but it's not there in the single inheritance. So multiple inheritance involves a subclass inheriting from multiple parent class, and it is more complex hierarchy with multiple paths for inheritance. There is a higher chance of ambiguity, especially when parent class have a overlapping attributes or methods, like attributes or methods with the same name. If they are there in the parents class, then child class will obviously get confused like what name or what attributes it needs to take. That causes the ambiguity problem in the multiple inheritance. So that was a basic difference in the multiple inheritance and the single inheritance. I hope you understood. Now let's move on to another topic, which is overlapping versus disjoint subclass. So in case of overlapping subclass, what happens? This happens when some entity share some common instances. Like if passenger entity and employee entity are there, and passenger also have passenger name and employee also has name attribute. So basically name is there in both passenger and employee. So we will be having a new entity with that common entity here name. That is called the overlapping. So used in scenario where entities share some feature but also possess unique traits. So person can be both passenger and an employee. So let's suppose in the railway station, a passenger person can be passenger, yes, and it can be the employee in the railway station as well. So a person can behave like passenger and employee both at the same time, and that is called the overlapping condition. Next is disjoint subclass. This is totally opposite to it. Here it do not share any instances or any and it cannot belong to only one subclass. So basically used when entities are distinctly categorized without overlap, ensure clear separation. So this is totally opposite to the overlapping subclass. Here no such properties remain same. Example is, let's suppose we have a train, right? So we know that we have two different types of train. One is passenger train and one is freight train, which actually handles goods, right? Handles goods like petrol, oil, to carry goods. So freight train and passenger trains are basically two different categories of train. So this comes under the disjoint subclasses. So train can be categorized in this passenger train or freight train, but not both. So disjoint subclass basically means when none of the property is same for the two entities. But in overlapping subclass, it happens when a single entity can behave as two different entities at the same time. So this is the difference between the overlapping and the disjoint subclass. Now next is partial participation. So in last to last lecture we have learned about total participation, means where all the entities were having some relation with the another instances of the entities, right? But in this case it will be partially happening, and that is why it's called partial participation. So it indicates that not all instances of a subclass are required to relate to an instance of a superclass. So in this scenario, certain subclass may exist without a corresponding to the superclass. So it might happen that in both the entities they do not have the accurate relationship. So for some instances it might happen that it is not there in the superclass even. So this type of participation is useful in cases where subclasses may represent optional characteristics or where not every entity needs to be associated with the parent class. So let's try to understand with the example. We have a train table, okay, and we have trains like Rajdhani, Shatabdi, Duronto or Garib Rath. So basically we have with train ID, source to destination address as well. Now, out of these trains, it might happen because of some maintenance, a strike, weather issue or technical issue, those trains get cancelled. So, in the cancelled train, we have Rajdhani here also, Shatabdi here also, Duronto here also. But Garib Nath has not been cancelled. So, it's not there in the cancelled train. So, not all trains are cancelled, but when a train is cancelled, a cancellation record is created. Therefore, the train entity participants partially in the relationship. So here we can say only these three are there in the cancelled train. This fourth one is not there. So they are basically partially participating in the entity, and that is called partial participation. Now let's see total participation. So total participation mandates that every instance of a subclass must be linked to the instance of superclass. So this is subclass. Okay. So from subclass, every instance should be linked to the instance of the superclass. This relationship ensures that subclass is always meaningful within the context of the parent class. So let's suppose here is an example called train table, and here is we are having the booking table, right? So whatever, like you can see 101, 103 and 102 and 104. Out of that 101 and 103 are there, right? 101 and 103 train ID is there in the bookings table. So total participation is important to maintain the integrity of the data model and ensure that every instance of the subclass has a relevant association with the parent class. So here every booking must be associated with a train. So booking ID we have as 201, 202, 203 and 204. Obviously it will be unique, right? Because every bookings are unique. So here booking must be associated with a train. So 201 is associated with 101. Like two person with the booking ID 201 and 202 have booked the seats in the same train 101, right? So basically if there is a booking, it must be correspond to an actual train. Hence the booking entity is total participation. So for every booking ID, there should be the train ID as well, right? So for every booking ID, there should be train ID. Like every booking ID is totally participating with the train entity. That is called total participation. None of the booking ID can exist without a train ID, right? So this can't happen. So this is the example of total participation, where all the instances, like all the instances means all the booking ID from the booking table will have the relationship with the train ID from the train table, because none of the booking ID can exist without a train ID. Basically, train bookings are only done in the train, right? So that is the example of the total participation. That was all about the whole lecture, where we learned about inheritance, single versus multiple inheritance, and also we have learned about partial participation and total participation. That was all about the whole lecture. I hope you learned. Now let's meet in another lecture. Till then, keep learning. Take care of yourself and your family too.